chemical element is a chemical substance that cannot be broken down into other substances by chemical reactions. The basic particle that constitutes a chemical element is the atom. In part, atoms are formed by protons and neutrons in the center, the nuclei, except for hydrogen, which doesn't have a neutron on its more abundant form. These subparticles, the neutrons and protons, are kept together by the famous gluons, basically energy that works like superglue. And surrounding the nuclei are the electrons, like moons orbiting and pulling in other atoms to play and team up with. Although protons, neutrons and electrons are made each of the same thing, the amount of them in each atom for each element determines its chemical properties given by its generated nuclear forces. Chemical elements are identified by the number of protons in the nuclei of their atoms, known as the element's atomic number. For example, oxygen has an atomic number of 8, meaning that each oxygen atom has 8 protons in its nucleus. 2 or more atoms of the same element can combine to form molecules, in contrast to chemical compounds or mixtures, which contain atoms of different elements. Atoms can be transformed into different elements in nuclear reactions, which change an atom's atomic number, like ionization or fission or fusion. Almost all of the baryonic matter of the universe, baryons, are basically kept together by the gluons to make the protons and neutrons, is composed of chemical elements. Among rare exceptions are neutron stars. When different elements undergo chemical reactions, atoms are rearranged into new compounds held together by chemical bonds. Only a few elements, such as silver and gold, are found uncombined as relatively pure native element minerals. Nearly all other naturally occurring elements occur in the earth as compounds or mixtures. Air is primarily a mixture of molecular nitrogen and oxygen, though it does contain compounds including carbon dioxide and water, as well as atomic argon, a noble gas which is chemically inert and therefore does not undergo chemical reactions. Don't worry, the iron in your blood and lungs only pulls in the oxygen mainly so you can breathe. The history of the discovery and use of the elements began with primitive human societies that discovered native minerals like carbon, sulfur, copper and gold, though the concept of a chemical element was not yet understood. Attempts to classify materials such as these resulted in the concepts of classical elements, alchemy, and various similar theories throughout human history. Much of the modern understanding of elements developed from the work of Dmitry Mendeleev, a Russian chemist who published the first recognizable periodic table in 1869. This table organizes the elements by increasing atomic number into rows, periods, in which the columns, groups, share recurring, periodic, physical and chemical properties. The periodic table summarizes various properties of the elements, allowing chemists to derive relationships between them and to make predictions about compounds and potential new ones. By November 2016, the International Union of Pure and Applied Chemistry had recognized a total of 118 elements. The first 94 occur naturally on Earth, and the remaining 24 are synthetic elements produced in nuclear reactions. Save for unstable radioactive elements, radionuclides, which decay quickly, nearly all of the elements are available industrially in varying amounts. The discovery and synthesis of further new elements is an ongoing area of scientific study. So, what's your favorite nuclear force?